I just give you the feedback, the broad picture of the system, how it works. You have multi-dimensional feedback to the engineering system. So like one system works, it gives the feedback to the another system. That system doesn't work, then it goes back to the previous system. And then, so this is very technical, okay, which as a engineering manager and engineering in charge, you need to know if one system doesn't perform, what will be the effect to the service, and which area will be affected in the building, and what will be the services affected, and how you're going to monitor it, how you're going to tackle it, what are the area need to be isolated, what are the area need to be what area need to be having the alternative for that. So this is a one typical system loop which you can see is a multi-dimensional. Okay, next I just give you the example of hot water distribution system in the guest room. Guest, once he open the tap, he see if the water quality is good. So to have a good water quality in the guest rooms with the proper temperatures, you can see how many systems we need to check the incoming city water quality. Okay, we need to have the we need to maintain the water level in the bulk tank. We need to have the metering there. We need to have the proper chlorine maintained on that. We need to have proper uh, pH balance in the water. Okay, after that we need to transfer that water through the transfer pump, or maybe moving to the gravity tank on the roof. From there, then it's been distributed to the pipe, and then in the from the top, then we got the risers in the between. So in those risers, the pipes, how it has been insulated, how it been carried, and what are the treatments we need to do in the riser so the water quality is clear and is maintain the temperature. Like once we talk about the hot waters, as we previously mentioned, so we need to maintain 48-degree temperature in the guest room. To maintain the 48-degree temperature, we need to see what are the temperature we are maintaining our storage tank. Okay, and then what is the insulation we need to have on our pipe, so at least we don't lose the temperature from distribution. So these are the key components engineer has to think, and he need to see if I'm maintaining 48-degree temperature in the guest rooms, what should be my temperature on the storage tank, what are the insulation factors, and what are the key factors play the roles when the water is being transferred, and how I need to unused water I need to bring back to the storage tank and then reheat it and then bring back to the guest room. So these are the very technical process which we need to think about. Yeah. Okay. So next system I have introduced is the guest in the guest rooms to maintain the air quality and maintain the temperature, the human comfort temperature, which is 22 to 24 degrees. Okay, to do that, so the cycle starts from the main chiller. Okay, so in the main chiller we need to maintain a certain temperature. Then in the chiller itself we have the components which need to work, and if those components doesn't work, we will not able to achieve a desired output of the air conditioning system. So where you can see the compressors, condenser, cooling towers, evaporators, chilled water circulation pump, then chilled water distribution pipes in the building, then chilled water pressure and temperature in the pipes, and then guest room. Once it comes to the guest rooms, then your fan coil units in the guest room, what should be your grill temperature, what should be your water temperature and pressure there. And to maintain 24-degree temperature, so you need to see what temperature is your chiller design should be, on what temperature you should run your chiller so to achieve 22-degree temperature in the guest room, and what are the air quality you need to, how you're going to filter your airs. Okay, what are the components you should have to make sure in your fan coil units, so that once the air being circulated in the room is odor free, is dust free, and it maintains the correct temperature in the guest room. So that's how the uh, circuits works in there, and every circuits have the feedback. So if in between this cycle one is failed, means you are not able to achieve the desired uh, output.
Oh, this is very fascinating system. So
Yeah.
it clearly shows that the hotel systems are highly integrated with one and another. So if system doesn't work properly, it will affect the entire chain to get a normal temperature in the. This is the building integrated system. So we are not talking about here the split AC which are easy to maintain. So these are these systems. Let's say if there is a problem with the fan coil unit, whatever however efficient your main chiller is working, your compressor is working, your cooling towers are working, the gas will not get their temperature, right temperature. And there are problems when a lot of so troubleshooting engineers need to understand the entire system. And the design, it also starts with the design process, how the building is designed, what are the external temperature, what are the internal temperature, what is the ventilation in the building. So the engineering team has to be trained on every aspect of the systems, on each and every component. And when you are doing the troubleshooting, if the, let's say there is not enough temperature, so not, instead of fixing only one system, we need to understand what is the root cause of the problem. Is it our chiller is not working, our cooling tower is not working, our pressure is not enough, or there is an insulation problem that you said, that there is an insulation loss during the transportation from main chiller to the guest room. There is always a loss of heat, there is a loss of cooling, which also need to be controlled, because it will reflect the efficiency and also the operating cost of the system as well.
Yeah. Thank you, Manish. Okay. To get water, as we mentioned, to get out water from the basin tap in the guest room, we really need to ensure many components or on equipment must work well, and they are interrelated, as I mentioned before. So if one system fail in between, definitely you will not have the desired output of getting the water in the guest rooms. Okay, so we need to know each components, each equipment, how it works, what is the output from this, and what is the effect if this equipment fails, what is going to happen. So at mention, your engineering team who is on the in charge of operation, they need to know the basic of the system. They need to know where to look the problem. They need to know how complex it is. They need to know what to do, how to do, and where to do. So that's what in the initial slides we asked. So your team, yourself need to know how, where, when, and who going to do it. So that these are the questions which is for each systems we need to know as a operation uh, in charge. So this matrix is been prepared for each and every system in the hotel. So to know, to rectify the problem, if the problem arise, how to do it. Because 24/7 you cannot be in on the operation, you cannot be on the field. So your team is on the field for 24/7. So your team is key responsible for handling all those issues, so they need to know what to do. Yeah. Okay, in engineering MEP system we have many such pictures as I have mentioned. So every system has to be same, one input, second system output. So if you take a building management system, it's the same. If you take hot water, we already explained. Air conditioning, we already explained. When you talk about the boiler, it's the same. If boiler doesn't work, you will not able to run the laundry. You will not able to provide the hot water in the building. So this is a whole system. Every system has the same picture. Every system has the same. If even we talk about, if engineering is not able to fix the kitchen equipment, chef will not able to cook. Okay, if chef is not able to cook, F&B is not going to serve. And same goes to the housekeeping. If there's a equipment which is faulty and engineering is not able to fix, definitely housekeeping will not able to clean the room. When the room is not clean, definitely you will have the problem. So this is a whole system, and then you can correlate, if this system doesn't work, what service is going to affect. Okay, so we need to study those pictures. We need to know the schematics of those pictures. As engineers, we call it schematic drawings of each system. So every building has a schematic drawings for each component, each equipment. So that you need to study. You need to know, okay, if my system, this system supply to this area, this system supply to this area, this system has these components, and these components feedback goes to here. So once you know all this system, it will be very easy to look for the problem if you face the problem in any area in your hotel.
So if you join any hotel and you don't have the schematic design or the pictures, probably the first task would be to draw these pictures.
Draw these pictures and look for the pictures, because every project, these are the first things which is with store, which is been produced. So your system cannot be designed without having the schematic drawing. So these are the key components, and these are the very valuable documents for any property, any hotels, to and any building, to these schematic to have as a record as a engineers, because this is not only for your operation. These are required for your licensing purpose. This is required from your government authorities to see. If we talk about the fire life safety system, it's the same. If you don't have the schematic drawings of your fire alarm system, when you go for your license renewal, first thing they will ask you, show me your schematic drawings. So this is very key components and key systems which you need to really know your schematic, and this has to be stored in your secure areas.